Hi, everyone. So how do you graph y equals x to the 0? Well, what is 2 to the 0? What's 3 to the 0? What's negative pi all to the 0? All of these are equal to 1. Remember the rules of exponents? These are all equal to 1. However, 0 to the 0 is kind of weird. Some books say that 0 to the 0 is undefined. In calculus, you talk about the 0 to the 0 indeterminate limit form, where the base and the exponent approach 0. But now, 0 to the 0 is sometimes defined as 1, especially if you're dealing with polynomial theory. So for example, if I'm talking about polynomial theory, I might refer to 1 as 1x to the 0, where x to the 0 is simply 1, even in the case where x is 0. So if I'm talking about polynomials, like in chapter 2 especially, then I may adopt this convention. So it kind of depends. If 0, okay, well, first of all, how do you graph y equals 1? You agreed that this is still basically y equals 1. How do you graph y equals 1? It's going to be a horizontal line. Although, if you say that 0 to the 0 is undefined, then you have a hole at 0, 1. Because if you're saying that 0 is not in the domain of x here, then you're not allowed to have a point there. So we have a hole. If you define 0 to the 0 to be 1, however, then you can spackle in that hole and just get your usual line, y equals 1, if you define 0 to the 0 to be 1. Desmos, for example, when you graph y equals x to the 0, it basically graphs y equals 1, and it appears to define 0 to the 0 to be 1 on Desmos. Of course, on Desmos, you often deal with polynomials. In either case, though, whether there's a hole at 0, 1 or not, we have symmetry about the y-axis. And therefore, in either case, the the x to the 0 function is an even function in either case. It's basically a constant function. Remember, constant functions are even. Constant functions are even. That was true for y equals 1. That was true for y equals 3 all the way up here. Okay, this was an even function. All constant functions are even. All constant functions are even. Whether you have f of x equals 1, 2, 3, negative 3, even 0. In fact, that represents both an even and odd function. All constant functions are even. That might sound strange because if I say f of x equals 3, you might be saying, wait a minute, isn't 3 an odd number? Yes, 3 is an odd integer, but we don't care. We don't distinguish between even and odd integers. 3 is a constant. All constant functions are even functions. This represents an even function. I don't care that 3 is an odd integer. All constant functions are even functions. I know that's confusing. Next up, what happens if we have y equals x to a negative integer? How do you graph those things? That's next time.